Hi everyone, Dr. Vaughn. I also have a request to do problem 3 from chapter 8, so here it goes. In this case, we have some data that are given to you. I clicked on this icon and actually already loaded those data into Excel. And now we're going to construct a 99% confidence interval for the population mean. We know the sample size, and then we're going to just replace one of the values with something else. But here's what's important on this particular one. They don't give us the population mean or the population standard deviation. So we're going to have to use the sample standard deviation instead, which means that we're going to be doing a t distribution instead of a z distribution. So that's the critical thing here. So we want to construct this 99% confidence interval. Once again, I'm going to reconstruct this may not be the same as the worksheet that I did in class, but we'll get through it. So first, I'm going to compute the population mean by doing the average equals average of the data points that I have. I'm going to insert a column just so I have some room to work with, and we'll just remind ourselves this is the mean, sample mean. Then I'm also going to compute the sample standard deviation, which is equals stdev.s, sample standard deviation. All right, and let's see, we're going to put in the confidence level, which is going to be 99%. And I think that's all the data that we have from the original problem. Now we're going to construct a 99% confidence interval for the population mean using the formula. So the thing here, we need to compute the t value instead of the z value. And then we're going to use s instead of the sigma in the confidence interval formula. I don't have the PowerPoints up. You can look into Chapter 8 PowerPoints for the t unknown population standard deviation confidence interval formula. It's pretty much the same as the confidence interval formula for the population mean. When the standard deviation is known, we're just using a t distribution instead of a z distribution, and we're using the sample standard deviation instead of the given population standard deviation. So I need to compute this t alpha divided by 2. And so this is going to be the value that I use in the confidence interval formula times the standard error, which gives me the margin of error, and then plus or minus that from the population, the sample mean. So I'm going to do the same thing pretty much that I did for the normal distribution, which is the t dot inverse, the inverse t distribution. And on this case, I can use the two-tailed distribution, two-tailed inverse. And then for the probability, I want the amount that's in the tail to be the 1 minus the confidence level. So I'm going to take 100% minus the confidence level, which is in cell B12, and then the degrees of freedom is n minus 1. So here I have 1, 2, 3, 4, 5, 6, 7 data items. So I'm going to put 6 in for my degrees of freedom. So this gives me that t cutoff value. It's really plus or minus. It's giving me the positive one in this particular case. And now I'm ready to compute the low end, the high end of the confidence interval. So confidence interval low. So we're going to start by taking the sample mean in the middle. So that's in cell B10, and subtract, because we're going to the low end, the t value now times the standard error. And the standard error is the sample standard deviation divided by the square root of n. So I'm going to take times the sample standard deviation and then divided by SQRT parentheses of 7, because there's 7 data items here. And that should give me the low end of the confidence interval, minus 1.4. The confidence interval high is going to be the same thing, just we take the sample mean. This time we do plus, and then the t alpha divided by 2 score times the standard deviation divided by the square root of n, which is 7, and That should be the high end of the confidence interval. So we'll round these to 2 decimal places and see if we got it right. Negative 1.40 and 11.69. Okay, now we're going to do the same thing. We're going to replace the value 15 with a 7 and then find the confidence interval again. The nice thing is that all I have to do is change this 15 to a 7 and everything else should stay the same and everything else should update automatically. So I'm going to put 0.97 and 7.03. And then we just want to look at what the effects of an outlier are. So in the first case, we had an outlier. 15 was kind of far away from all the rest of the numbers. And so in this case, we had a pretty wide confidence interval. And if you go back, you could look at the effect on the standard deviation and everything else. So the presence of an outlier, it increased the value of the sample mean, and it greatly inflates the sample standard deviation, and it widens the confidence interval. So that's C. And then that's it for question 3. All right, well, short and sweet. I hope you enjoyed this video. Talk to you later.